Hey class, here's a hint to get you started on problem 27, and that's my wife in the background laughing at me. Nope, this is staying. Nope, sorry. Anyway, so in this problem you're asked to solve for the current I1 through the resistor shown here, and you're asked to find current I2 through the resistor shown here, and then you're also asked later on in the problem to determine what the power is going through EMF1 and then the power being output really by EMF1 and EMF2. Alright, so we can go ahead and maybe call those P1 for the one going through power EMF1 and P2. So the question is, how do we go about figuring these out? Well, the first thing we do is we need to label our currents going through each of the different objects in our circuit. So if we say that the current is going this way through EMF2, I'm going to call that I2 since it'll be the same current going through this resistor here. The current going through I1, I'm going to say is also going in this direction, same as I2 here. And then the current going through here is some different current. I'm going to call it I3 because you can observe that there's a junction at this location here, so the current going through EMF1 is different than I1. I think that's a common mistake people ran into. Then we also can observe that the current up here going through this resistor, since it has the same resistance as all the other resistors, the current here is actually also going to be I2, and then the current through each of these two resistors in parallel is going to be I2 over 2 because they are two resistors of equal magnitude and they're in parallel with our current I2, so you could derive that from doing a junction rule at this location as well, or this location for that matter. Okay, so that's what we got. So in order to solve for some of the different currents that we're looking for, we need to do a couple loops. So I'm going to go ahead and define two separate loops. I'm going to erase a few things just because it's getting tricky in here. Well, I better leave this here. Okay, anyway, so my first loop is going to be going through this small circle here. So this here is going to be my loop A, and then my second loop that we'll be doing later is going to be the loop going around here, and we can call that loop B. So you're going to want to use each of those two to set up your Kirchhoff's rules, and so doing the loop rule, if we look at loop A for example, what do we have? Well, if we start down here at EMF2, we're going to have E2 as a positive value. Then next we would go through this resistor here, and so that's going to be, we're moving again in the opposite direction of the current, so that's going to be positive I1 multiplied by R. And then we're going to have going through the next one up here a negative I2 times R. Then going through this resistor next, we're going to have negative I2 over 2, as we established was the current through that resistor multiplied by R. And then lastly we come to this resistor here, which would be minus I2 times R, and that's all equal to 0. So we can see from our first loop that we are unable to solve for any one of our variables just yet because we do not know what I1 is and we do not know what I2 is. So we're going to really start with loop B instead, and many of you might have went with loop B initially, but I did not. So for loop B it's much simpler. All you have is EMF1, and then you have minus I1R, and that's it. A nice simple loop, so you can easily solve for I1 here, and then you can use that and plug it back in to try to solve for I2. Now the key on this problem that a lot of people ran into having issues with was actually determining the powers. So the power is really just equal to the current multiplied by the voltage. And so the key to realize here is if you do the P1, it's going to be equal to the current through EMF1. So that's I3 multiplied by the magnitude of EMF1. That's the key in realizing that I3 is different than I1. And similarly for power 2, as we acknowledged earlier, the power through, the current through EMF number 2 over here was our same I2 value, so similarly you could say P2 equals E2 times I2. Anyway, best of luck. Hope you have a good night.